We now discuss the solution of a problem from the section Coordinate Geometry. This problem is related to the concepts of hyperbola. This question has appeared in the Joint Entrance Examination Main held on 28th June 2022 in the first shift. The given question is, let the eccentricity of the hyperbola h, whose equation is x square by a square minus y square by b square is equal to 1 be under the square root of 5 by 2 and the length of its lattice rectum be 6 root 2. If y is equal to 2x plus c is a tangent to the hyperbola h, then the value of c square is equal to. We are given four options. Option A 18, option B 20, option C 24, option D 32. We have the hyperbola h given by x square by a square minus y square by b square is equal to 1. It is given the eccentricity of this hyperbola as under the square root of 5 by 2 and it is given its length of lattice rectum is 6 root 2. If y is equal to x plus c is a tangent to a hyperbola h, required to find the value of c square. We now discuss the solution of the problem in detail. We have the hyperbola h given by x square by a square minus y square by b square is equal to 1. Given its eccentricity e as under the square root of 5 by 2, the formula for the eccentricity of the hyperbola is given by e square is equal to 1 plus b by a whole square and that will be e square will be 5 by 2. Agreed. We are also given length of lattice rectum as 6 root 2. The length of the lattice rectum for this hyperbola is given by 2 times b square by a and that is equal to 6 root 2. A tangent to the hyperbola h is given by y is equal to mx plus or minus under the square root of a square m square minus b square. We are given y is equal to 2x plus c is a tangent to this hyperbola. So comparing these two equations, m is equal to 2 and c is equal to c square is equal to a square m square minus b square. Agreed. So this will imply m is equal to 2 and under the square root of a square m square minus b square is equal to plus or minus c, okay, c, and squaring on both sides, c square is equal to a square m square minus b square, where m is 2, so it will be 4a square minus b square. So we want what are the values of a square and b square for this hyperbola with these properties. So we will go back to 1 plus b square by a square is equal to 5 by 2. So 1 plus b square by a square is equal to 5 by 2. This will give you b square by a square is equal to 5 by 2 minus 1, that is equal to 3 by 2. And this will imply 2b square is equal to 3a square. So our intention is to obtain the values of a square and b square. Now again we go to the length of the lattice rectum. So 2b square by a is equal to 6 root 2. So 2b square is equal to 6 times root 2a. Now from these two, 2b square is 3a square. 2b square is equal to 6 root 2a, equating we will get 3a square is equal to 6 times root 2a. And after cancellation, you will get a is equal to 2 root 2. We want a square. A square is equal to 8. Agreed. We will go back to 2p square is equal to 3a square. In that we substitute a square is equal to 8. Then you will get 2b square is equal to 3 times a square is 8. 2b square is equal to 24. B square is equal to 12. So thus we got a square is 8, b square is equal to 12. We will go back here and substitute the values of a square and b square. Now we go back and substitute, that is 4 times a square is 8 minus b square is 12. And 4 8s are 32 minus 12, that is equal to 20. So the answer for this question is c square is equal to 20. Let's look at our options. Our answer 20 appears against option B. Therefore, the answer to this question is on option B. So, that is the detailed discussion of the solution of the problem, which is based on the concepts of hyperbola, and I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.